In problem number 2, we're trying to find the minimum distance between a point P that has coordinates x, y, and the point on this curve y equals x squared minus 8, and the point 0, negative 1. Probably the most difficult part of solving this problem is understanding what it actually means. So this is the picture of what it means, and I would hope that any time you are trying to set up a function, you would draw a picture. And labeling the picture, it helps you understand what you're supposed to do, where you're supposed to put the numbers and letters and symbols and all that. So the other thing that I did was I expressed, instead of the coordinates x, y, I expressed them as x comma x squared minus 8, because any point on the curve will have a y coordinate of x squared minus 8. So that's one of the keys to the problems as well, these kinds of problems. Then the distance formula is given over here, a little background behind where that distance formula comes from. And then going ahead and expressing the distance between these 2 points using the y coordinate, or just using y as the y coordinate. So we have the difference in the y coordinates squared plus the difference in the x coordinates squared. Of course, with a plus sign you can interchange the order. I'm not sure why I used the y's first there, but then if you simplify this expression, y minus negative 1 to y plus 1, and then substitute in x squared minus 8 for y, simplifying gives us x squared minus 7 quantity squared, multiplying that out, and simplifying underneath the radical, we get the distance is equal to what we see here, the square root of x to the 4th minus 13x squared plus 49. So that's part A. That's the answer for part A.